We're going to cover how quantum computers work without needing a PhD to understand how. Quantum computers aren't just superpowered versions of the computers we use today. They play by completely different rules, thanks to quantum mechanics, one of the most mind bending fields in physics. I'm not going to throw a bunch of equations at you because I won't understand them either. Instead, I'll explain everything using simple analogies and examples. Let's begin by reviewing how the computers we use today work. At their core, computers work using binary digits, or bits. Everything is either a 1 or a 0, like flipping a coin. Every action, from sending a text to watching Netflix, is just a crazy fast sequence of switching between these two states. On its own, a single bit is useless. It's like trying to write a novel with just one letter. But by stacking billions of these tiny coin flips together, we can represent numbers, letters, images, sound, everything digital. Let's make bits and bytes a little easier to visualize. 8 bits equals 1 byte. That's like a single letter in a string of text. Kilobytes are thousands of bytes. Think of a short paragraph. Megabytes, millions of bytes. That's a book. Gigabytes, billions of bytes, a library. Terabytes are trillions of bytes. That's like an entire university's library system. And petabytes are quadrillions of bytes. Think of all the academic libraries in the US combined. Now imagine a computer made up of billions of tiny coin flips happening every second. That's how your laptop or phone processes information, one step at a time, flipping digital coins like crazy. Let's use a video as an example of how many coin flips take place. A typical video runs at 30 frames per second. A 5-minute video is 300 seconds. With 30 frames per second, it's 9,000 frames. Each frame is a high resolution image, typically 1920 by 1080 pixels, otherwise known as 1080p, which is 2,073,600 pixels per frame. Each pixel stores color information using RGB, red, green, blue values, typically requiring 24 bits per pixel. So for one frame, that comes out to 49,766,400 bits. Therefore, a 5-minute 1080p video at 30 frames requires at least 450 billion coin flips just to store the raw data. These coin flips are powerful stuff, but there's a hard limit to how much faster classical computers can get. No matter how powerful they become, they're still just flipping coins. Here's where quantum computers change the game. Instead of just flipping a coin and getting heads or tails, imagine you spin a coin on the table. While it's spinning, is it heads or tails? Neither. It's both, until you stop it. That's what superposition is. A classical computer bit can only be a 1 or a 0, but a qubit quantum bit, thanks to superposition, can be 1, 0, or any combination of both at the same time, like 0, 0, 0, 1, 1, 0, and 1, 1. If a regular computer flips one coin at a time, a quantum computer spins every coin at once, exploring multiple possibilities simultaneously. Let's say you're in a maze and you need to find the exit. A regular computer would check one path at a time until it finds the right way out. A quantum computer can explore all possible paths at the same time and instantly knows which one is correct. That's why quantum computers have the potential to solve problems in seconds that would take classical computers thousands of years to do. Alright, now let's make things even weirder. Imagine you and a friend each have a coin, and you both flip them at the exact same time. Normally, those two flips would have nothing to do with each other, they're just random. But in the quantum world, if the two coins are entangled, something crazy happens. If they're entangled to match, then the moment you stop your coin, your friend's coin instantly lands on the matching side. If they're entangled to differ, the moment you stop your coin, your friend's coin instantly lands on the opposite side. What's wild is that it doesn't matter if the coins are in the same room or across the galaxy. That's quantum entanglement. It's 100% real and 100% mystifying. Einstein called quantum entanglement spooky action at a distance. The discovery of quantum entanglement upends our current understanding of the physical universe. It's mind blowing stuff, but how does it apply to quantum computers? With entanglement, quantum computers can communicate instantly across qubits. Regular computers have to send information bit by bit, but entangled qubits would share data instantly. They can also perform massive calculations in parallel. Instead of working one step at a time, an entangled quantum system can process an entire problem at once. It can also build quantum networks. One day, entanglement could enable ultra secure quantum communication, where hacking is nearly physically impossible. So you may be thinking, where's my quantum computer? Unfortunately, quantum computers aren't replacing your laptop or phone anytime soon. It'll probably be a lot like computing back in the 60s, where a computer would take up an entire room of an office building. Here's why. One, they need to be insanely cold, near absolute zero, because heat and tiny vibrations can destroy the quantum states. They're very fragile. Even a small disturbance, heat, light, or noise, can mess up their calculations. And we're still just figuring them out. Right now, they only solve very specific problems, but not general tasks that your everyday consumer would use it for. Quantum computers are weird, powerful, and nowhere near finished, but they will utterly revolutionize how we live. So the next time someone asks, "What's the deal with quantum computing?" just tell them, it's like flipping a coin versus spinning a coin. Regular computers flip them, quantum computers spin them all at once. If you like this, hit subscribe for more mind blowing tech explainers, and let me know in the comments what's the most interesting use case you've heard for quantum computing. Thanks for watching.